Goedenavond allemaal. Welkom bij de tweede editie van Café Scientifique van dit collegejaar. En Café Scientifique is altijd al een samenwerking. Dat weten misschien sommigen van jullie wel. Het wordt georganiseerd door studieverenigingen van de Beta-faculteit, FNWI. In samenwerking met de praktijk. Een jong bedrijf wat zich richt op wetenschap, promotie. Dit leg ik niet goed uit, maar vraag dat in de pauze bij Alex. De praktijk. Alleen deze editie is een hele speciale editie, omdat het ook samen wordt georganiseerd met Future Planet Studies. Een studie van het IIS. Dat is het laatste wat ik daarover zeg, maar het belangrijkste is dat het gaat over Groene Herfst. En dat is dit boek, geschreven door Egbert Tellegen, pardon. Dat gaat over 50 jaar milieu. Daar gaan we het vanavond over hebben, met 3 sprekers. Maar omdat het een speciale editie is, doe ik dit vanavond niet alleen. Dus ik wil jullie graag voorstellen aan Kim, staat daar voor jullie klaar. En ze vertelt even kort wat haar rol vanavond is.
Hallo, mijn naam is Kim. Ik ben student Future Planet Studies. En ongeveer 2 maanden geleden zijn Neske en ik benaderd door het Instituut voor Interdisciplinaire Studies om professor Egbert Tellegen te interviewen. Wij waren erg enthousiast hierover en we hebben meteen het boek gelezen, uiteraard. En dat bleek eigenlijk een redelijk goed thema te zijn om ook interdisciplinair een lezingenavond over te organiseren. En toen zijn we naar Café Scientifique gestapt om dit waar te maken. En ik ben ontzettend blij dat jullie hier allemaal gekomen zijn. En in mijn rol vanavond is eigenlijk jullie mening laten horen. Dus als jullie bij de stellingen of bij de vragen iets willen zeggen, roepen, schreeuwen, vinden, zwaai naar mij en ik kom zo goed mogelijk naar je toe met de microfoon. Dat was het eigenlijk.
Yes, dankjewel. Voordat we beginnen, toch wel even wat huisregels. Het is een interactieve avond. Ondanks dat ze in de 2 maanden tijd die verstreken is sinds de laatste editie een podium hebben gebouwd, wil niet zeggen dat het niet interactief is en dat jullie niet ook dingen mogen zeggen. Dus steek je hand inderdaad op. Er mag ook bier gehaald worden ondertussen. Dat jullie dat weten. We gaan het vandaag hebben over milieu, maar met name over de toekomst van het milieu. Heeft het milieu nog toekomst? En zo ja, hoe ziet die toekomst eruit en wat is onze rol daarin? Daar gaan we het vandaag over hebben. Ik wil graag de eerste spreekster introduceren. En voor de naam spiek ik even achter op het bord, als jullie het goed vinden. Ik weet het wel, maar om het toch goed uit te spreken. Judy Shamoun Baranes. Zeg ik dat goed? Applaus. En het volgende.
Eerst wil ik de organisatoren bedanken voor het eer om bij zo'n gelegenheid te spreken bij Groene Herfst. En jullie zeker bedanken voor het aankomst in het sneeuw, mooie wintersweer. En nu is mijn Nederlands helemaal op voor de volgende kwartiertje, dus ik ga overstappen in Engels. Maar als jullie iets niet begrijpen of ik praat te snel, dan even stoppen of iets roepen en ik ga wat langzamer praten. So what I'd like to do in the next 15 minutes is show you some examples about how the consequences of climate change can be very complex for ecological systems. And I think that if we want to change our behavior, adapt our behavior to make a positive change, we need to understand some of these processes and what the interactions really are. And at the end of the presentation, I'll also show you a little bit of how, in our own research, we incorporated a lot of new technology to try and understand how animals, and specifically birds, interact with our environment so that we can understand these processes better. So, one of the first examples I want to talk about is DDT. It's one of the most infamous, you can say, examples about bioaccumulation in the environment, about poisoning, in fact, of the environment. And DDT was used, was discovered quite some time ago. It was used intensively already during World War II. Basically to stop or destroy disease-spreading vectors, insects, to control malaria and other diseases. But after World War II, DDT was used extensively in agriculture, basically for pest control. And it was used in home gardens, it was used basically everywhere. And as you can see from one of these advertisements, it was really advertised as the cure-all, the end-all to insect problems, any kind of insect problems. It was sprayed in large quantities and, as I said, extremely prevalent in the environment. But at some point in the 60s, in the 50s already, people started noticing that birds were disappearing, predominantly small songbirds, songvogels. And they also noticed that birds, particularly after DDT was spread between residents and so on, they actually found dead birds in the garden. They also noticed that the populations were decreasing, and there was a link easily made with DDT. So people started complaining, but nobody was listening, in fact, at least for quite some while. And what they also found out with time was that the problem was not only that DDT was killing, of course, insects directly, but species that were eating insects, and then as DDT was accumulating in the food chain, eating those organisms, DDT was collecting, and it wasn't, in fact, breaking down, it wasn't disappearing for the environment, it had a very, very long lifespan in the environment. It was causing longer and longer problems, which took time to notice. So one of the main problems, in fact, so we had a first problem in the lower trophic levels where small birds were disappearing that ate insects. But afterwards, what we started noticing was that as you went up in the, I have to look here, as you look up in the trophic levels, DDT was also being washed into the water, basically. It was it was not soluble in water, but it was soluble in fat. So it was incorporated into our cells, in fact, into many, many organisms. And what was happening was that birds, particularly large raptors that were eating other organisms and having higher concentrations of DDT, they weren't dying directly from the poison. But what was happening was that the poison was basically DDT was interfering with their reproductive systems. So males were becoming infertile, and females, when they were laying their eggs, they laid eggs with softer and thinner shells. So basically, they couldn't reproduce. So populations were crashing. So in 1962, a famous book was published, Silent Spring, which had a huge impact on the environment, and basically was an outcry for many, many people. And it really showed how books, so scientists were speaking, and we're telling people, we're talking to the Environmental Protection Agency and saying, listen, we have a problem. But nobody was really listening. Nothing was changing. This book came out, and it was written for the general public, and people started listening. People started noticing that was a huge problem. They started noticing that their own gardens were becoming quiet. The birds weren't there anymore. So in 1972, and people often attribute it as a very strong result of this book, DDT was banned. It was banned in America in agricultural use. It was also banned in Europe and in many other countries. And what we saw, in fact, as a result, is that many species very, very quickly recovered. I say quickly, but it took several decades. What you can see up here is an example of a common bird in the Netherlands, the buzzard. And the species also basically almost disappeared from the Netherlands, but with the ban of DDT, the population started increasing again. And what you can see in the maps, I don't have a pointer, so it's a bit awkward to turn around, is that not only did the population increase with time, but it also increased its range. It started expanding its range within the Netherlands, but also in Europe. So it's good, right? Some species really did well. Lots of programs to conserve species. One of the nice, beautiful examples in the US is the bald eagle, which almost went extinct. Of course, a symbol of the United States, so it was important that the species would survive. And again, a fish-eating species at the top of the food chain, so it was actually a species that was very susceptible to bioaccumulation, but again, recovering and doing very, very well. It's now taken off of the threatened list. But other species, like the Californian condor, have basically almost completely disappeared from the environment. And what happened was, so people noticed that in the 1980s, there were only 10 individuals left. Now they had already seen, well, we stopped DDT already 10 years ago, so what is the problem? But these species breed so slowly, they only lay one egg every 2 years. They take 4 to 5, sometimes 10 years to reach sexual maturity. So the change takes too long, and at this point the population had reached such a low level that it couldn't recuperate on its own. So they started an incredible program. They captured all of the birds, 10, put them in captivity. It's a small number, and it is really crazy to capture an entire wild population. Put it in captivity, start a reproduction program basically in zoos around the world, and started releasing these birds several years ago. They're doing okay, but not great. And the question still was, they've done the same program for the Andean condor. And these birds, if you don't know them, and many of you probably don't, these birds are incredible. They have a wingspan of 3 meters, if you can imagine. Twice my size, basically. Fantastic birds. They need a lot of open space. And these birds have not been doing well. These birds have not been recovering. And one of the reasons is that it's not only about DDT. These birds are losing their habitats. They're still suffering from other kinds of problems like lead poisoning, but even things you wouldn't think about, like electrocution when they sit on electrical power lines, or even suffering from eating small pieces of garbage. So a lot of these problems, when we can solve one problem, it doesn't necessarily, for example, save an entire species. It depends very much on that particular species and its very, very specific ecology. Another strange thing that's become a problem for many of these raptors is what we would see as a positive attitude to the environment, but has had a negative effect on these birds. So one of the things that's changed is that as animals die in the landscape naturally, let's say a deer, sheep, or cow, we don't leave them anymore just lying around, right? You never see, has anyone here ever seen a dead cow in a field? I'm shocked. Okay, I never have. Most of the time, they're collected immediately by veterinary services to avoid the spread of disease. But all of these birds are scavengers. They need large, dead animals to feed on. But these are collected and never or rarely left, apparently twice, they've been left in the field, but it rarely happens anymore, and especially not in the clean and organized Netherlands. So that's another problem that these animals face, and we're trying to now correct by putting animals, dead animals, in the fields to stimulate the population. So, one complex story in a very short period of time. The other one I want to explain, which is a little bit subtler than the example of DDT, is what we call ecological mismatch. And this is one where we see, everybody knows, so I don't have to show the graphs of temperature rising in the last 100 years, but everybody knows that temperature is increasing. Has been fluctuating during history of Earth, so that's nothing new, but apparently the rate of change is much higher than it's been before. The problem is that many ecological systems cannot keep up. So what we do see is that as temperatures are increasing, they don't increase at the same rate in every place, they don't increase at the same amount in every place, but systems are trying or are keeping up. They are adapting to a certain extent. So what we see is as temperatures increase, the graph below shows you mean temperatures in spring and the relationship to the first flowering day or the mean flowering day of the Pinksterbloem. So I also thought that was funny, to Pinksterbloem, but it doesn't bloom in Pinksteren, which is in June, May. But if you look at the dates here, it now blooms somewhere in March. And that's because spring is starting sooner. So temperatures are rising, it's much warmer, the flowers are blooming earlier. That's an example of earlier spring, early greenness. What we do see, so what's the problem? These flowers are adapting, they're doing fine. The problem is higher up in the food chain. So what we see is that many insectivorous species, birds that eat insects, can't keep up. Or they can, but to only a small extent. What happens is, while some parts of the food chain, like plants, will keep up and will start blooming sooner, will show their high peaks in productivity sooner, the next trophic level, for example, insects, larvae, butterflies that feed on the plants, they also have to reproduce sooner in order to keep up with a high productivity. If everything is supposed to be optimal in nature, they should all be well timed together. And in fact, evolution has worked towards this type of optimality. And what we see with many of these insectivorous species is that, for example, the great tit, the koolmees, you should all know it, I hope. So the koolmees is very, very well synchronized with its main food source, which are larvae of butterfly. The birds start breeding right before the peak of the larvae, and once the larvae peak, usually these birds have all of their eggs hatching so that they have a maximum amount of food available when they need it. But what's been happening now, and that's what you can see on the graphs at the bottom, is that the synchronicity is in fact not matched anymore. So while spring is occurring much earlier, birds can breed a little bit earlier, but not quite enough. So only a part of the population is well synchronized. Still, maybe not a major problem. Most of the birds are managing. But we do have species which are migrants, like the pied flycatchers, the bird on the right. The problem for these species, this is another example, is the boerenzwaluw. You can imagine they migrate thousands and thousands of kilometers. They still have to deal with spring.